Okay, so we're going to work through the November 21 Paper 2 Intermediate Numeracy exam for the WJEC. It's Paper 2, so this is one where you're expected to be able to use a calculator. So let's get stuck in. Dilwyn draws a conversion graph to help him understand his geography homework. He's looking at areas, both in square meters and acres. So with any graph, first thing to do, make sure you understand what the axes are providing you as far as data and what the units are. So usually with these conversion graphs, in order to add a bit of challenge to them, you've got some strange units going on, and you can see that here. So on the horizontal axis, which is acres, which is the metric, the imperial measure for area, you can see there that 0.1 is 20 squares, or 2 big squares, and the first question is to do with 0.05 acres. Well, if that's 0.1, 0.05 would be halfway between there and there. That would be, if you imagine that that would be 10 pence in pounds, 5 pence would be 0.05 in pounds, which would be there. So that's the 0.05. So what you are needing to do is to read up to the conversion point and across. Now we can see that that's exactly halfway between 0 and 405. And remember, you're allowed to use a calculator. So 405 divided by 2 is 202.5. So to my list, it's 202.5 that I'm looking for. Which of the following is equivalent to 0.3 acres? Circle your answer. Well, 0.3 is there. Even though the graph doesn't extend beyond 0.25, because it's a conversion graph rather than just raw data, we can just extend that. And if we were to extend it, we will see that the point that we need to read off is the very limit of the graph, which is that point. Now, because these have to be going up in equal jumps, that one goes from 0 to 405 in 20 squares. If you add 405 to 405, you get 810. So to get the value up there, we need to add 405 to 810. So if you need to use a calculator, 405 plus 810 is 1215. So 1215 meters squared is what you're looking for. Okay, question 2a is a utilities bill question. So utilities bill generally is a gas bill or an electricity bill where you are charged per unit of whatever energy you are using. So if there's electricity, for every unit of electricity. And somewhere in your house, usually by the front door, there's a meter, there's an electricity meter or a gas meter. And just like with your mileage, a mile meter in a car, it clicks over the unit. So in a car, it would be clicking over, once you've driven a mile, it would increase. So it's frozen at the point where you last paid your bill. So the meter reading then was 34560. And then once you paid the bill, it clicks up to where it freezes to measure the next bill, when the meter has now moved on to 35180. So the first thing you need to do here is work out how many units of electricity you've used. And you do that by subtracting these values to work out the difference between them. So 35180 take away 34560 equals 620. So you've used, or sorry, Mr. Khan has used 620 units of electricity that he has to pay for. So the charge for electricity is the number of units he's used, and you're going to multiply that by 18 pence. But you're paying your bill in pounds. Everything's in pounds. So when you're multiplying, you're actually going to be multiplying by 0.18. That would be 18 pence written in pounds. So 620 multiplied by 0.18 is that, which would be 111, and then the 0.6 would be £1.60 in terms of money. So that's how much you're paying for the units. If you used more units, you'd pay more than that. If you used less units, you'd pay less than that. The next part of a utility bill tends to be a standing charge. This is a fixed charge that you are paid whether you use any electricity or not. It's basically you're paying for the connection of electricity to your house, or the gas line that runs to your house. So that's fixed. In this instance, it's giving you what the total of that is. In some questions, and you need to be careful about this, it will tell you that it's £6 a month, and you need to work out what it is for 3 months, and that would be an additional calculation you would need to do. But here, it's worked it out for you, £6 a month for 3 months, £18. So the total charges that you have to pay are the £111.60 plus the £18, which is £129.60. So that's the cost of your electricity bill. But in addition to that, you pay a tax, a value-added tax, which is for heating or for utilities, 5%. Value-added tax for your shopping, if you went shopping, would be 20%. But on energy at the moment, it's at 5%. So we need to now add on, or find out what 5% of that is, in order to add that onto the bill. So £129.60, I need to multiply that by 5%. On a calculator, you can just type times 5, and then use the percent button, which is shift and the ants button. Okay, so mine says ants times 5% because the £129.60 was already on the screen. So you press equals, and that's £6.48. If you don't want to use the percentage button, if you're used to writing 5% as a decimal, then that's fine. You could have just typed in £129.60 times 0.05. Whatever method you are comfortable with for working out percentages, that's what you use. So the total amount that needs to be paid is the £129.60 charge for the electricity plus the value-added tax. So £6.48 plus £129.60 equals £136 and 8 pence. Now that's about as straightforward a utility bills question as you could get. The only bit you need to remember, the place I see so many students going wrong, is what to do with these two figures here in order to work out what's been used. Okay, the most common mistake is to add them together, to think that you need to find a total of the two rather than the difference between the two. So just be careful of that. Part B. So this is our OCW question. This is where you will earn an additional 2 marks to getting the maths right if you've laid it out in a sensible or clearly communicated way and you're consistent with your units. That's broadly what you need to consider. So Mr. Khan currently has each of the following bills to pay: water bill, gas bill, loan repayment. If Mr. Khan waits until next month to pay these bills, he will pay a month's interest on each of the bills. Interest is charged for the month as listed below. So he will pay 2% of £234 on water, 2.3% of £120 on his gas, and 11% of £45 on his loan. Calculate the total interest. Now, when I was marking your work over the weekend, this was a really common mistake, was you weren't working out the total interest, you were working out the total bill, which would be working out the interest and then adding it on to all of what needs to be paid. For the total interest, you just need to work out what each of these are. So water is going to be £234 multiplied by 2%. So we can work out what that is. Center button, remember? My light isn't great here for some reason today. So that's £4.68. If you want to write that as 0.02, that's absolutely fine. Gas is going to be 120 times 2.3%. So 120 times 2.3%, £2.76, or 120 times 0.023. The common mistake to make if you're changing that to decimal in your head would be to write it as 0.23, which is in fact 23%, so be careful with that. And the loan is going to be 45 multiplied by 11%. So that's £4.95. So those are the interest payments that Mr. Khan has to make. So the total interest would be the sum of these. So 468 plus 276 plus 495. £4.68 plus £2.76 plus £4.95 equals £12.39. And that's it. The maths is the 5 marks is for getting £2.39. And then the 2 marks for the OCW are for basically writing those 1, 2, 3, 4, 5 words which clearly explain what you're doing, and then consistently where you've got an answer, sticking a pound sign in front of it. So I haven't put pound signs there, not needed, but I have there because that is the payment that needs to be made. Similarly, I haven't there, but I have there. So pretty straightforward 7 marks there. Question 3. Liam is following a recipe to make Welsh cakes. He places flour, butter and sugar in a mixing bowl. These 3 ingredients have a total mass of 1,920 grams. So if I was weighing that bowl, it would come to, the weighing scales would give me a total of 1920. He checks the recipe and finds the mass of sugar is 3/16 the total mass of these ingredients. And for every 90 grams of sugar, he needs to add 1 egg and 50 grams of sultanas. Calculate the number of eggs and the mass of the sultanas that Liam needs to make his Welsh cakes. Okay, so before I can work out the egg and the sultanas, they both tie in to every 90 grams of sugar. So the first thing I need to do is work out how much sugar there actually is. And it's telling me, so mass of sugar. Now with this, there's no marks for the way you laid out, but it still makes sense to help you and the marker work out what you're doing here. So the mass of the sugar is 3/16 of, now the word of, I haven't got an of button on my calculator anywhere. The of button is the multiplication. If I'm finding 3/16 of 1920, that's the sum that I have to do. Now on your calculator, as I've said many times, this is one of the best buttons on the calculator, the fraction button. So we press that, we have a 3 on the top and a 16 on the bottom. Then you move the cursor across and do times 1920, and you get 360 grams of sugar. Okay, so we've got 360 grams of sugar, and for every 90 grams of sugar we need to add 1 egg. So every 90 that goes into there is going to require 1 egg. So the number of eggs will be how many times 90 goes in to 360. So 360 divided by 94. So 4 eggs. And for every 90 grams of sugar, so for every 4 of them, you need to have 50 grams of sultanas. So mass of sultanas will be 50 lots of 4 is 200 grams. So we've got 4 eggs and 200 grams of sultanas. Serena is making a sauce. The mass of the flour Serena has in a mixing bowl is double the mass of butter. The total mass of flour and butter is 825 grams. So for every gram of butter you've got 2 grams of flour. Double the mass of butter to get the mass of flour. So that's actually telling you that you've got, if I've got flour to butter, for 1 part butter I've got 2 parts flour. So if I've got 10 grams of butter, I've got 20 grams of flour, and I want to work out how that's divided in 852 grams. So what I have to do in a ratio question like this is divide that 852 by 3, because I need to break it up into 3 parts. So 852 divided by 3 is 284. So 1 part is going to be 284, 2 parts is going to be 568. So calculate the mass of flour, 568 grams. Let's make that a bit clearer. So because the mass of one is twice the other, that means that you've got a ratio of 2 to 1. Question 4. Ms. Ritter is buying a new dining table. She's seen a table with a circular top and another with a rectangular top. The circular top has a diameter of 1.5 meters and the rectangular top measures 2 meters by 0.8. Which of the tabletops has the greater perimeter? You must show all your working. So the perimeter is the distance around the outside of the shape. So if we've got a rectangular table which measures 2 by 0.8, because it's rectangular, that means you've got 2 parallel sides of 2 and 2 parallel sides of 0.8. The perimeter is the sum of those lengths. So the perimeter will be 2 plus 2 plus 0.8 plus 0.8, which is 5.6 meters. The circular version of perimeter is the circumference. And you're not given the formula for the circumference of a circle. You've got to remember it. It's one of the ones that I make you write down on that formula page at the start. The circumference of a circle is pi times diameter, and with this one is telling me that the diameter is 1.5. So that's going to be 2 pi times 1.5. On your calculator you've got a pi button, which is, mine is above that times 10 to the x. So you just need to be sure where that is with yours. So I'm going to do shift times 1.5 equals, now mine works it out automatically as a decimal, yours might write it like 3 over 2 pi or something like that. We need it as a decimal because we want to compare it with that. So 4.7 meters will do, because that wants to 1 decimal place. So I've done all the maths, but I haven't answered the question yet. And again, when I was marking your work over the weekend, a couple of you lost marks here because you didn't conclude which of the tabletops has the greater perimeter the rectangular one. Rectangular has greater perimeter. So with that question, there's a method mark for working out the perimeters, an answer mark, A1 for getting them right, and then an E1 for concluding. B. Does the tabletop show the greater perimeter also have, does the tabletop with the greater perimeter also have the greater area? So now we've got to work out the area. So the area of the rectangle is going to be length times width. Again, you're not given that, you need to know that. So 2 times 0.8 is 1.6 square meters. Now for the area of a circle, again you need to know this, is pi times the radius squared. Radius is half the diameter. It's the distance from the center to the outside the circumference of the circle. So that's going to be 0.75. So back to pi times 0.75 squared. Not sure if you need the brackets, you might just be able to type it. And that works out to be 1.8 square meters if we round that to one decimal place. So does the tabletop with the greater perimeter, well the rectangle had the greater perimeter, but the rectangle has got the smaller area. So does the tabletop with greater perimeter also have the greater area? No. Circular has greater area. So exactly the same marks as for part A. There's a method mark for working out the areas, an answer mark for getting the 1.6 and the 1.8 or the 1.77, and then an E mark for the conclusion that the circle has the larger area. Question 5. So a bottle contains 250 grams of sun cream. A website recommends that one application of sun cream is 1 ounce. So this is a metric to imperial conversion. 250 grams is metric, 1 ounce is imperial. And this isn't one of the ones you're expected to know, so they're giving you some information there. They're telling you that 1 gram is 1,000 milligrams, and 1 ounce is 28,350 milligrams. So the first thing that we need to do is finish reading the question. Use this recommendation to answer the following question. About how many applications of sun cream are there in this bottle? So in order to answer that, I need to know how many ounces there are in the bottle, because every ounce is an application. So I need to convert that 250 grams into ounces. So the first thing to do is to turn 250 grams into milligrams, because the conversion that they're giving me is in milligrams to ounces. So 250 grams, every one of those is 1,000 milligrams. So I'm going to multiply 250 by 1,000, which is basically going to be 25 followed by 4 zeros. So it's 250,000 milligrams. And then to turn it into ounces, every ounce is going to take up 28,350 of those. So in order to turn it into ounces, I want to see how many of those go in to that amount of suntan lotion. So I'm going to divide that by 28,350. So 2, 5, 1, 2, 3, 4 zeros divided by 28350, 8.81 blah blah blah, ounces. So you could say 8 full applications, you get the mark. Say 8.8 applications, doesn't matter. If the question said there how many complete applications, you'd say 8. In bottle. Basically, as soon as they see the 8.8, you're going to get your 3 marks. Part B. Marie wants to buy some sun cream. So a small bottle, 100ml for £1.42, a large bottle, 250ml for £365. Which of the two bottles of sun cream offers the better value for money, the small or the large? Now it's a tick box, but if you just guess and you just tick, you won't get any marks. So this is a value for money best buy question, where what you need to do is to make the quantities the same and then compare the costs. So there's lots of different ways of doing this, and when I mark your work, you've all got slightly different methods. What I'm going to do is double that to get 500ml and multiply that by 5 to get 500ml. So I'm comparing 5 by 5. You could work out 2.5 of those, or you could divide that by 2.5 to get 100ml. It really doesn't matter, as long as you're comparing like with like. So if I do 500ml of small, then that's going to be 5 lots of 142. £7.10. 500ml of large would be 2 lots of £3.65. £7.30. So now I'm comparing like with like. I can see the small bottle is better value. Question 6. In the science lesson, 13 students calculated an estimate of the area of their skin. The results are shown on the scatter diagram below. So I've got the area of the skin on the vertical axis. Note that it doesn't start at 0 because there's no data below 1.2, so they've broken the axis there. And similarly horizontally, they've broken the axis. It doesn't start, there's nothing before a height of 1.5 meters. A. Arwin is the only student who has made an error in his calculation. He is one of the tallest students. What is Arwin's calculated estimate of the area of his skin? So height is the horizontal axis. So one of the tallest students is going to be up here, and we can see that we've got this one point here which is way out of the rest of the data. So that dot there is Arwin. What was Arwin's calculated estimate of the area? So that's going to be 2 squares up from the base of the graph there, 2 squares up. So let's have a look here. We're going from 1 to 1.2 in 10 little squares. So halfway there is going to be 1.1. So we're going to be going up in 0.02. 1.02, 1.04, 1.06, 1.08, 1.1, and so on. So that one is 1.04. Which term best describes the correlation between a person's height and the estimate of the area of the skin? Well, correlation is the general pattern of the plots of the points that have been plotted, and if they're both increasing, so with this you can see that as the height increases, so does the area of the skin. So if they're both increasing, that's a positive correlation. So just to remind you, if we've got generally an upward set of dots, that is positive. If as one piece of data increases, its corresponding decreases, so we get a sort of downward slope. That would be negative. And if we get a graph where there's no apparent slope, there would just be no correlation. So I got that positive. So it isn't no correlation. Spread has got nothing to do, it's a rogue word there, nothing to do with scatter. Certain is probability, it's got nothing to do with it. Positive or negative, it's positive. Garth is 5 centimeters taller than Ella. The calculated estimate of the area of Ella's skin is 1.54. How tall is Garth? So we're going to use the information about Ella's skin area to locate her on the graph. 1.54, that's your 1.5, 1.52, 1.54 is there, which if you go across is that one there. So that's Ella. Garth is 5 centimeters taller than Ella. Well, Ella is 1.6 meters. So it's 5 centimeters is that. Garth is going to be 1.65 meters tall. Bryn is 1.5 meters tall. Abigail is 18% taller than Bryn. Okay, so we're going to increase Bryn by 18, which means I'm going to multiply by 118%. Or you could work out 18 and add it on, doesn't matter. But it's an increase of 18, so it's going to be 118%. So my calculator, remember I used my percentage button. No, you can't see that, sorry. There you go, 1.5 times 118% is 1.77 meters. So I've then got to work out, so Abigail is 18% taller than Bryn, so Abigail is 1.77 meters tall. So this is going up in 1.75, 76, 77, 78, 79. So two little squares is 1. So 0.77 is 1.75, 76, 77 there. So that's Abigail. And we want to know the area of her skin, which is there, which would be halfway between 1.8 and 2, which is 1.9 square meters. So don't be shy of, when you've identified something, marking that on your scatter diagram. It does make it easier. Just to show you, if you didn't want to do the 118%, if you just wanted to do 1.5 times 18%, sorry, 1.5 times 18% is 0.27, and then add that on, you still get the 1.77. So whichever method you're happiest working with. Question 7. On Monday, Mrs. Griffin recorded the time each of her students took to start a task. She records the data in groups of equal width. Mrs. Griffin displays the results in a frequency polygon as shown below. So we've got frequency going from 0 up in tens, and then we've got the time going across in fives. So this point here is telling me that in the group, now what, this is a different way of representing a group frequency diagram. So sometimes you wouldn't see the frequency polygon, you would see the connected bars. So the point is at the frequency, the height of the bar, and at the midpoint of the category. So it's another way of representing grouped data. Okay, so I'm putting in the columns just because for some of you it might be easier to help you figure out what on earth is going on here. So sometimes they'll talk about a grouped frequency diagram, which will be what you see in pink. Sometimes they talk about a frequency polygon, which is what you were presented with. Frequency polygons are usually used if they're going to draw more than one set of data on the same graph. Because with columns, you can't see behind the columns, so it just gets a bit confusing. So on Monday, how many students started the task? So the height of each bar is the number of students in that group. So here we've got 30, 35, 37 students completed, took between 5 and 10 seconds to start the task. This one is 34, this one is 20, 28, 21. So to work out the total number of students, I've got to add 37, 34, 20, 28, and 21. 37 plus 34 plus 20 plus 28 plus 21, 140 students. Which is the modal group of the times taken to start the task? So the modal group is the group with most students in, which is this one, because that's 37, which takes you from between 5 and 10. So that's your answer. Part C. In which group is the median time taken to start? Well, I know I've got 140 students, all in order. The 37 fastest are there, followed by the 34 next fastest. So for the median, I've got to find the middle. So I'm looking for the 70th student. Now, it's important to write that down, because even if you get no further, you are recognizing that you're looking for the 70th. So you get a mark for writing that down, even if you then get the wrong group. So because the group are in order, I know that the first 37 are there. So by the time I reach that point, I've walked past 37 of the kids. I keep walking, and if I get to this point, I've walked past 37, 67, 71 of them. I'm looking for the 70th, so the 70th pupil is in this group here, which is the 10 to 15. So that's the median. Mrs. Griffin had set a target that students should start work within 30 seconds. Was the target met? So within 30 seconds, here's 30 seconds, and you can see that in the next category, which takes you beyond 30 seconds, there are no students in that category. So all the students have started within that 30. So was the target met? Yes. And then you want to say something like, because there are no students in the 30 to 35 group. On Tuesday, the same students started the same task again. 25% of them started the task within 10 seconds. Is this an improvement on the number of students who started the task within 10 seconds on Monday? You must show you're working. Okay, so on Tuesday, 25% started within 10 seconds. It's the same kids, so it's out of 140. So 25% of 140, remember of is the multiply. So, why can't I get any light? 25% times 140 So 35 started within 10 seconds on Tuesday. Now if we look at how many started within 10 seconds on Monday, and we can see that 37 started on Monday. So is it improvement? No, it's not an improvement. There are fewer that have done that. Question 8 is a exchange rates question. So Terra Rose Currency Exchange. They buy currency, £1 buys $1.36, but the only notes that are available are in whole 5s, 10s, 20s, 50s and 100. Neris is going on holiday to the USA for 13 days and then on to Italy for 7. She's saved a total of £500. Okay, so she's got £500 to buy US dollars and euros. Neris takes 13/20ths of her savings to buy US dollars from Terra Rose Currency Exchange. She wants to buy as many dollars as possible. Neris plans to use all her remaining money to buy euros. How many dollars will she buy? And how much money, correct in the nearest penny, will she have left to buy euros? So 13/20ths of her savings she's going to use to buy dollars. So let's work out what that is of 500, and that's going to be in pounds. So fraction button, 13 on top, 20 on the bottom, times 500, £325 to buy dollars. Every one of those gets that much dollars. So in dollars she gets 325 times 136. $442. But you can't buy $442 because you can't make 442 out of the notes that are available to you. The most she can buy will be 440 because there's no dollar coins or single dollar notes. So although she's got £325 to spend, she's not going to be able to spend that because she can only buy $440. So these will cost, and in order to work out what that's going to be now, I've got to do the 440 divided by 136 to turn that value back into pounds. So 440 divided by 136. So we need to round that to the nearest penny. So it's going to be £323.53 because the next digit is 5 or higher. So 323.53 pounds. So that's how much she's going to spend on dollars. Then she's going to use all her remaining money to buy euros. So how much money will she have left to buy euros? So to buy euros, she starts with 500 quid and she's going to be spending that much on dollars. So I'm going to do 500 take away 323.53, £176.47 is what she's going to use to buy euros. So that's a really straightforward question this late in the paper. The only thing you need to spot is the bit about what notes are available. And we practice questions like that in class. Question 9. Elwyn makes 10 full jugs of fresh lemonade. Each jug is cylindrical, with internal measurements as follows. So it's a cylindrical jug. Height of 28, base radius of 5 centimeters. Elwyn's drinking glasses each hold a serving of 170 cubic centimeters of lemonade, and he serves 80 people lemonade. How many full jugs of lemonade does Elwyn have left over? You must show all your working. Right, so we've got a cylinder. Again, one of the things that I would have encouraged you to write on the formula page would be the formula for the volume of a cylinder. The volume of a cylinder is the area of its circular face, which is pi r squared, times the height. So will give us the volume. So we can work out the volume of one jug. So vol of one jug will be pi times 5 squared times 28. Which is pi times 5 squared times 28 equals 2199.11, etc., etc., etc. And we'll round that to 2,200. It's as close as that. So, and that's in cubic centimeters. So the volume of one jug is 2,200. Elwyn's drinking glasses each hold a serving of 170 cubic centimeters, and he serves 80 people lemonade. So we can work out how much lemonade he needs. So volume of lemonade served will be 80 lots of 170. One 13600 centimeters cubed. So he will serve 33,600 centimeters cubed. So if you want to work out how many jugs that takes, I want to work out how many times that fits into that. So the number of jugs required will be 33,600 divided by 22,000. I've done something wrong there, haven't I? 80 times 170 is 13,600. Why have I written 33,600? Okay, make sure you're happy with my mistake there. I've got the 80 times 170 written down, and that's the calculation I've done. But then for some reason I wrote 33, not 13600. So 13600 divided by 2200, 6.18, so 6.2 jugs. So he needs just over 6 jugs to fill those 80 glasses, and he's made 10 jugs. So number of jugs left will be 10 minus 6.2 equals 3.8. So 3.8 jugs, but the question is asking how many full jugs 3 full jugs. So there's other ways you could have gone about that, and some of you did, but so long as you follow your logic. So I've worked out the volume of 1 jug, total amount of lemonade volume required, then I've seen how many jugs we need to produce that quantity of lemonade, and it was 6.2, but I know we've actually got 10 full jugs, so that means we've got 3.8 left over, 3 of them are full, 1 of them's got 0.8 in. And then we come to the final question, which looks terrifying because of the amount of information they're giving you. Mr. Reed is building a shelter against his house. So there's a photo of it, it's a sort of lean-to for his car. The length of the shelter is 6 meters. Okay. He's drawn a sketch of the side view of the shelter as shown below. Mr. Reed has started to place some panels on his roof. When fitted to the roof, each panel needs to slightly overlap the next panel. The plan view of placing the first 3 panels is also shown below. So if we look side on, okay, so if we're standing there looking side on, then we've got this trapezium shape, the ground, the house outside of the wall, and then to make the roof on a slope so the rain runs off it, we've got that upward there, and we can see there that what we've got is actually a right angle triangle where I know 2 of the sides and I don't know the length of the panel. And then the plan view is if you're flying above it and looking downwards. So if you're looking downwards at that, you can see here that there are 3 panels there. That's the first one, and then we've got a little bit of overlap so that there's no gap that the rain can fall through. Diagram not drawn to scale, so I can't measure anything. The shelter roof panels are 1 meter wide and can be bought in different lengths, and depending on what length you want has an impact on the cost. Mr. Reed bought the cheapest suitable panels to build his shelter roof. Calculate the cost of all the panels Mr. Reed bought. You must show all your working. So in order to use this table, I need to find the length of the panel. So if I just do a little drawing, whenever you've got a complicated diagram, just lift out what you want. I want to find out what that length is there. So I called it L. And I know that this is 4.2 and that is 1.1. So you need to recognize that I'm looking at a right angle triangle where I know 2 of the sides and I want to find the third, and remember that that is Pythag. When you're working with Pythag, I remember I need to square my sides. So I need to do my 4.2 squared is 17.64. So if I say 4.2 squared equals 17.64, and my 1.1 squared is 1.21. What I've then got to decide is, am I going to add those or subtract them? And the way you decide that is figuring out whether or not you're trying to find the longest side in the triangle or one of the shorter ones. The longest side is always the hypotenuse. It's always pointed at, if you think of that, by the turning the little box into an arrowhead. So that's my longest side. In order to find the longest side, I need to make a bigger value out of these 2. So I'm going to add them together. And that will give me the square of the other side. So L squared will be 17.64 plus 1.21. So L squared is 18.85. Now I don't want the square, I want the original. So I've got to do the opposite of squaring, which is square rooting. So I can just do square root of ants is 4.34 meters. So the distance between that point and that point measures at 4.34 meters. So if I was to buy a length of panel which is 4.3, that's actually going to be too short and it'll fall down. So I'm going to have to buy the 4.4 meter panel. So this is the panel that I'm going to buy. Now I've got to decide how many of them I need. And the panels are 1 meter wide, and that's a 6 meter distance. So if I bought 6 panels, I could not have any overlap. So I need to buy an additional panel in order to make sure that I can have this little overlap. So I need 7 panels at 4.4 meters, which is going to cost me 7 lots of £24, which is 168 quid. So it breaks down to a really straightforward piece of maths. It's a Pythag question where you're trying to find the longest side. So you add the squares and square root, and then you've got to relate that back to the information in the question. And finally, calculate the size of the angle between the shelter roof and the outside wall of the house. Give your answer to 3 significant figures. So that's an instruction. If we don't finish off doing that, out of those 4 marks, we're only going to end up with 3. So again here, I can see I've got a right angle triangle. That's 1.1, that's 4.2, and I want to work out what that angle there is, which I'll call x. So it's an angle. It's not Pythag, because you can't get any angles at a Pythag, so you're thinking trig. You have to think trig. Right angle triangle with an unknown angle. When you're working with trig, first thing you need to do is name your sides. So the one opposite the angle we're trying to work out is the opposite. The one the right angle box is pointing to is your hypotenuse, and the one that's left is the adjacent. Then on the front of your formula books, you will probably have written these down straight away in case you forgot them later. Those are your 3 trig relationships. You need to identify the one that contains both the opposite and the adjacent. And I can see there the only one that contains the opposite and the adjacent is tan. So I'm going to write that down here. And when you're trying to find the angle, as we are, the angle is linked to the S, the C, or the T. So tan of the angle is op over aj. So tan of my angle, which is x, equals op over aj. So tan of x is opposite, which is 4.2, over the adjacent, which is 1.1. Because we're trying to find the angle, I need to undo the tan x just to get the x on its own. And on your calculator, the opposite is above it. You can see it's got tan minus 1. So x is going to be tan minus 1 of 4.2 over 1.1. And you type it into your calculator then, exactly as we've written it there. So shift tan, fraction button, oops, that's not a fraction button, 4.2 on top, 1.1 underneath, move the bracket cursor over to close the bracket. So it's exactly as I've written it, equals 75.323. Now, I'm going to write that all down, just so that even if I get those significant figures wrong, I know that I'm going to earn the mark for the right angle. So the 3 most significant figures, when you're working with significant figures, you start counting immediately. So that's my first, that's my second, that's my third. You look at the next one along, it's less than 5, so they don't round. So my 3 significant figures 75.3 degrees. And you could put 3SF after it if you want, but you don't need to because that's their instruction to you. And that's it. That was the paper 2 from November 21.